Alright guys, here we're going to finish chapter 9.1, and today we're going to be talking about significance levels and the very controversial topic of a type 1 and a type 2 error. You thought I was going to say diabetes, but no, it's type 1, type 2 error, and the $1 million question. So you want to watch for all three of those. What is the significance level, type 1, type 2, error, and then what is the $1 million question? Okay, so significance level, and I'm actually going to extend this out so I can write on here. Significance level is actually always represented by alpha. Okay, and that is an alpha. And what the significance level means is where am I going to draw the line finally? Okay. And if you remember throughout this whole year, really, I've been kind of saying, where do we draw the line? Normally, where do we draw the line? And we usually draw the line at like 5%. If anything's smaller than 5%, odds are those aren't the best odds in the world. Okay? So, like, for instance, if you have a 4% chance of surviving the surgery, those aren't the best odds in the world. I wouldn't take them, all right? Or if you have a 3% chance of winning the lottery, well, never mind. Donahue probably would take that one. All right, so the significance level is normally done by alpha, okay? And we usually draw it at 0.5. That means if we could have a 5% error, that means how confident are we really? 95, right? We're 95% sure of our results, 5% not so sure. Okay? Sometimes we want only 1% error. Obviously, then we would be more sure of ourselves. Okay? But remember, anything lower than the significance level means we reject the null. Okay, so if it's lower than whatever the significance level is, we reject the null. Okay, maybe I'll put that on there. Lower than, sorry guys, I'm writing with my mouse, than this, reject. No, I'm sorry. You guys are painfully watching this right now. Well, my wife is painfully doing the dishes. Do you hear her? Man, she knows how to mess up a video.
Making muffins.
She's making muffins. So, all right. Company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Based on the years of experience, the company knows that its regular AAA battery lasts for 30 hours of continuous use. On average, the company selects a simple random sample of 15 new batteries and uses them continuously until they are completely drained. What would be our hypothesis? So, first of all, we are going to take and plead the fifth. I don't think that actually relates to anything we're doing right now. But we're going to say, all right, we're going to assume that the new batteries stay the same, right? They stay the same. And the old batteries lasted 30 hours, so we're going to assume the new batteries last 30 hours too, unless proven otherwise. So then my alternate hypothesis, what would be my alternate hypothesis? I'm going to put 30 here. I want to know. I've lost my train of thought. Now I can only think of that song. I want to know if the batteries are going to last longer. So I want to test to see, will this mean actually be larger? Okay, greater than 30. By the way, if you are having problems with your greater thans or less thans, okay, that is greater than, this is less than. Okay? There, that helps everything, right? No, I usually think less than looks like an L. Okay, if you want to remember that. Less than looks like an L. Okay. So if we have a resulting p-value, let's say we did all of our stats and all this kind of good stuff, and we actually got a p-value. Now remember, p-value is the probability of the event happening. Okay, if the null was true. So maybe I'll draw a little curve here, a normal curve. And we're going to say, all right, if the middle of that curve is actually at 30 hours, we got a p-value, so we got something that was up here that had about 0.02% chance of happening, if this was true. Okay? What conclusion can we make for a significance level? So let's say, all right, notice here's alpha. So let's say our significance level is set at 5%. Okay? Well, our p-value is lower, remember? If our p-value is lower than our significance level, we reject the null. Meaning, 2% chance, that's not too good odds that the null is actually true. Would you actually say, you have a 2% chance that the null is true? Are you going to take those odds? Okay, I'm not going to at this point because I'm drawing the line. The line has been set. Anything lower than 5%, I'm not accepting. So, I would say reject. Reject the null. Alright. The American Rejects. Those were a popular band when I was early on in college. Alright, what conclusion can we make if our significance level is 1%? So where are we drawing the line this time? We are drawing the line at 1%, right? So if we set a significance level of 1%, then what would happen with our p-value? Well, our p-value is actually greater than 1, isn't it, this time? So we would fail to reject. Fail to reject. Da, 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 da. All right. You understand? Since our p-value is larger than the significance value in this case, we would fail to reject it. Now, one other important thing. Before we do anything, if we're doing a statistical thing, we don't set the level of significance after we've done it. Because then it's just cheap. Because then we're like saying, let's set the significance level at 0.000001, so we will fail to reject our null. No, that's stupid. You set it before. Are you going to set it at a 5% level or a 1% level? And then you go and you move and you do your stats, and then you say, okay, well, I set the level before it all. I'm going to take it as it is. I told you this is how it's going to be. Now I got to fall through. It's kind of like that one time that we played that one stats game where we shouted out, and I think somebody said they got a video out of it or something. I don't know. We've watched plenty of videos in this class. So, all right. I held to it. All right. Type 1 and Type 2 error. These are the next things we have to move, and we got to go. We got 6 minutes left, and we got 2 slides to go. So testing a claim. A Type 1 error means we reject the null, but it's actually true. Okay, that's a pretty serious error. So let's say somebody's guilty. That's the null. Let's say the null means somebody's guilty. The null is guilty. Okay, if somebody's guilty, if we reject that null, we're saying they're not guilty, right? We're rejecting the null. So we're saying they're not guilty, let them off. But a type 1 error would be like, uh-oh, they actually are. OJ, okay, right? Okay, so if we reject the null, but it's true, so it'd be like saying they're not guilty, go, you have a good life, and then realize they are a mass murderer. Okay? Then, a type 2 error would be we fail to reject the null, but it's false. Alright, so this is where it kind of gets a little, which one's worse? So we fail to reject the null, alright, meaning, alright, we don't have enough evidence. We're going to say they're guilty. I'm reversing the whole thing. I don't know why I keep doing this, but the null would be obviously they're not guilty, but we'll just say they're guilty for old time's sake. Say we're like the, I don't know, 300 BC. I'm sure they had people be guilty, not be proven innocent right away. So if we fail to reject the null, but it's false, that means we say, hey, they're guilty. You're guilty! But then we later find out, ooh, they weren't guilty. Can we turn off that electrical chair? Or is it too late? Okay? So which one is a worse error? Now, we always run into story problems about like cancer, let's say. All right? And so let's say a null is that we're going to automatically say we got to prove it first. So let's say they don't have cancer. So that would be the null. So the null would be that they don't have cancer. I might run out of time again here today, guys. But let's say the null is that they don't have cancer. Okay, 3 more minutes. And like I said, I'm writing with my mouse. So nulls, they don't have cancer. So type 1 error would be we reject it. So we would actually say, you actually do have cancer. But it's actually true, meaning they don't have cancer. Alright? So this would be, we would say they do, but actually don't. Does that make sense? Alright, so that would be that case. And this error down here would be, we would say, you don't have cancer. So we would say you don't have it. But in reality, you actually do have it. Now, which is a worse error in that case? Would you rather think you have cancer, but not really have it? Or would you rather have people say, you don't have cancer, but really have it? Which is the lesser of two evils? Doctors and stuff, they tend to err more on this. They would rather say, you do have it, right? They would rather be more precautious and then find out later on, oh, actually, you know what? You don't have it. Okay, muffins are done. Well, then I'm going to have burnt muffins. Okay, I can't. I'm videotaping. I can't take them out of the oven. Alright, so read through this potato chip thing. Okay, try the potato chip problem. And I have about a minute left, so there's no way I'm going to be able to do the whole potato chip problem. But first of all, state what is the hypothesis. And then we would test, and then describe what you think the type 1 and type 2 error is. Okay, in both settings, and what would be the consequence. Alright, so read through it on the potato chip problem. State the hypothesis. Describe what a type 1 and type 2 error is. And explain the consequences of each. And then we can kind of weigh on which one's worse, which one's better. I'm going to pause it. You should pause it as well. And then just hit play. And for the last 10 seconds, I'll show you the answers. Alright, I'm back. Here's what I would say the hypothesis is. The potatoes, it's a probability, so it's a percentage. So I'm going to P equals 0.08. We're going to assume they all have that. And then we're going to have problems if it's greater than 8%. And then down here is what I would write for my errors. All right, guys, work hard, get your homework done.